Columbia, Houston, good morning to the blue team. That was cultural exchange for Dave.
Good morning, Stephanie. The blue team's up, and we're ready to go to work. Thanks a lot.
You are very welcome.
You're looking at a view of the moon taken from a camera in the payload bay of the Space Shuttle Columbia. Columbia currently orbiting the Earth over Central America, about to enter into orbital nighttime.
We now have a live view of an experiment on board the Space Shuttle Columbia. This camera view looking at the facility for absorption and surface tension submitted by the European Space Agency, which measures the response of surface tension to carefully controlled changes in the surface area of bubbles or droplets. In this view, there's a tube on the right that sometimes forms the bubbles or droplets that are being studied.
This live downlink on NASA television is from the initial run of the laminar soot process experiment, the LSP. This experiment looks to better understand the formation of soot. It's advantageous to do this experiment in the microgravity of low Earth orbit because the reactions in flame are slowed in that environment. Control of soot is important in more efficient, cleaner, and safer combustion. Soot can cause fires and reduce the durability of jet engines, and in addition, it's an atmospheric pollutant. This laminar soot process experiment is from the University of Michigan at Ann Arbor and is being conducted in the CM2, the Combustion Module 2 facility. That facility is designed to contain experiments related to flame, and the LSP is one of 3 such experiments on board STS-107. The other 2 experiments to be performed a little bit later in the mission are the water mist fire suppression experiment, or MIST, looking at better ways to extinguish flames, and the softball, structures of flame walls at low Lewis numbers, seeking to better understand how fire works. Again, those last 2 experiments to be performed a little bit later in the mission.
Columbia, Houston, a very good morning to the Red Team. We're looking forward to another productive day with you. The music was for Ilan. That was Hatishma Koli by Hakalonet Gavohim.
Good morning, Houston. It's great to be awake for a Hebrew, very old song by a very good singer. And it's great to be here in space and hear Hebrew. And thanks for my wife Rona and the kids, and we are looking for a great fourth science day for us here.
Thank you, Ilan. We're looking forward to that, too, and we enjoyed the music.
Good morning, everybody. This is Willy on our ergometer on the flight deck. He loves to exercise, as you can see. This view is one of the most outstanding ones that we've had during our time up here. It's a pass over Saudi Arabia and the Persian Gulf. You get a good idea of the incredible views of clouds and water, and combined with the land, here you see some red sand dunes. The views have been incredible. We also passed over San Diego today and could see the very dramatic coastline there, and had some other nice passes over the eastern seaboard. Unfortunately, we don't get as much time as we would like to look out the window, but at every opportunity we take a glance at our glorious planet. Here's Mike Anderson, our payload commander, working on the combustion module 2. He was getting it configured for some tests later today. He's inserting a special module into this rack to do the laminar soot process experiment that's looking at the basic physics of flames and how to prevent more soot from coming off of them. Again, here we have Ilan, Ramon, working on MEDEX. He's looking at a computer and commanding some radiometric cameras outside in the payload bay that are measuring the reflection off of dust in the atmosphere. It has a huge impact on weather patterns across the planet. Ilan, as you probably know, is from Israel, and we're proud to have him here on this flight with us. He's been an invaluable member of the crew. We couldn't work on board without computers, and here you see one of the dozen or so that we have on board, and we interface with almost all the experiments with these computers. Of course, the computers can't do it all. Here's Ilan looking out the window real time to see where the dust storms are most significant so that he can direct the cameras to the right place. Here's Kalpana Chawla, our American astronaut from India. She's working on an actual laminar soot process test that was done today. Ilan did one as well, and we're told the test came out wonderfully, and the investigators on the ground are thrilled with the results that they've gotten. Again, this experiment is looking at preventing any extra pollution and maximizing the efficiency of any number of types of different flames in engines or any other combustion process. Again, the PGSCs are invaluable. Well, this is me talking to the ground, discussing some changes in procedures for our bioreactor development system. We're growing cancer cells and bone cells together, looking at the signals that cancer cells send to bone cells. The tissues are doing wonderfully, but they wanted to make double sure that everything was going well, so the ground was telling me about some extra tests that they wanted to have done today. We performed those tests, and the tissues are growing well and metabolically very healthy. And Dave Brown was, again, our wonderful videographer who was showing me doing this. We unfortunately didn't get Dave on tape today, but we'll make sure we do that tomorrow. Here's Rick Husband, our commander. As you can see, being a commander entails a plethora of different activities. This is the mechanics of granular materials payload, which is looking at the physics of sand and solids, shifting soils in earthquakes. We're having a little bit of less than optimal packing of the sand, so Rick is attempting to take a big clump out, and this gives a new meaning to packing sand up here in space. Here again is one of our incredible views. This is the view that we're in for our Sol Slim attitude. This payload is from Goddard Space Flight Center, looking at the limb of the Earth, looking at the ozone across the limb of the Earth specifically. This is a closing shot of the limb of the Earth coming across the Appalachians down there at the bottom of the screen, coming toward the eastern seaboard of the United States of America. We're proud to have brought you this, and thank you very much. Goodbye.
Laurel, that was marvelous. Thanks very much for that great video.
Houston, we start off showing you an orbital sunrise from the shuttle. What happens in about an hour on the Earth happens as quickly as you're going to see it. This is a view out the back window when we're flying Payload Bay to the Earth. Orbiter at night is a very pale blue, but rapidly it'll become kind of reddish, turning to gold, and even brighter gold, and then the orbiter becomes quite white. So we're going 17,500 miles an hour, and it's a beautiful sight, and we get to see that sunset and sunrise every 45 minutes. This is from this morning, and the blue shift getting to work. We sleep in sleep stations, which are bunk stacked 4 high. This is Mike and his. There's 1 below and 2 above. To the right are some clothing lockers, and to the left are some checklists and saliva collection kits. First thing we do for part of our biology set of experiments is record how we slept. And so that's what Mike doing, is filling out a paper log. He's also got a saliva collection kit in his hand. Flight day 5 for the blue shift, and we pretty well got our sea legs, and we're getting adapted to sleeping in space, and actually starting to enjoy it quite a bit. Then, of course, it's time to get up and go to work, and looks like Mike was dressed to work from the start. Nice thing about microgravity is you can sleep in your clothes, and they don't get wrinkled. The middeck was pretty crowded this morning. We actually had all 7 crew members while we're doing our post-sleep activities and some payload ops at the same time. This is KC, and she's working on an experiment known as BioPack, which is from the European Space Agency. And she's working in a glove box, which keeps all the little small parts of the experiment and any liquid from escaping from where she's working. This particular experiment, actually there's 8 experiments in BioPack. The one she's working on is called Bones, and studies human bone cells, bone cell cultures, and looks at the balance between calcium deposits formation and calcium absorption, trying to understand better how to prevent osteoporosis, not only the kind of bone loss that astronauts get in space, but something that might affect people that are at bed rest, or actually that everyone is at risk for on Earth, particularly women. We have to restrain ourselves somehow, so we have these foot loops scattered around the orbiter. Now, BioPack has a centrifuge, so things are exposed to microgravity, and then the centrifuge provides artificial gravity, and you can compare the 2 types of cell cultures. Next up for the blue shift was a blood draw back in the space hab. Here Laurel is, I think she's telling Mike at the moment that this isn't going to hurt her a bit. It turned out we're going to do the blood draws up against the stowage rack, so we decided to use the straps to help restrain the subject and also make sure that Mike can't make a quick getaway from Laurel. These blood draws are part of a set of experiments called Physiology and Biology 4, or Physiology and Biochemistry 4, and there's 4 sets of experiments: protein turnover, calcium kinetics, renal stone risk, and latent virus shedding. We got quite a bit of stuff that we use for this, so we're provided with little clips of Velcro and the like to hold everything down. Of course, one thing about microgravity is instead of handing things, you can just pass them from one end of the module to the other, and
so that's really handy sometimes, the lack of gravity. Part of the blood sample goes now to Ilan, and he's working with a portable clinical blood analyzer. And so we take these samples within 10 minutes of the blood draw and record them for the payload scientists. So not only do we store some of the samples, actually we store all of the samples, but we do some real-time analysis in the HAB in space. We're kind of multitasking here in that we're using the combustion experiment as a workspace. So we kind of share all the space and all the payloads and take advantage of a spot when we can. This next clip, I'm going to step back to yesterday. This is Kalpana and Chawla working on the combustion module 2 experiment, and this was the very first burn of the laminar soot processes experiment, sponsored by the Glenn Research Center, and in particular Dr. Jerry Faith, our good friend. Combustion Module 2 looks at a variety of issues that we face here on Earth. We burn things all over the world, people do, and this experiment looks at not only making combustion cleaner, but also how to make it more efficient. And one experiment even looks at how to extinguish fires, so sometimes things burn and we don't want them to. This particular one, again, it looks at soot, and if we can even make a small decrease in the amount of pollution from combustion worldwide, that's a major contribution. So here's the first ignition sequence of the flight. You'll see a light coming on in the chamber. Next you'll see an igniter arm coming in. You'll see a good ignition. There's the flame. So here's the initial light off for combustion module 2 for STS-107. This flame is contained in a sealed cylinder. It's about 4 feet long by 3 feet in diameter, and we change out the hardware for each of the 3 major experiments in combustion module 2. The experiments run with a laptop computer, which you can see Casey working on. Here's her checklist. And we trained over the last 2 years on how to do these particular procedures, and so far all that training has really paid off. So congratulations to CM2. I'd like to finish this pass with a view flying over, right now, Egypt, passing to the Red Sea, and on the top left is the Sinai Peninsula. You can see some clouds overhead. Just coming into view are some contrails from jet aircraft. It's just been full of beautiful sights up here on STS-107, and the views out the window just don't stop being really, really great. Here we are continuing. Jordan will be on the left and Saudi Arabia to the right. So with that, I'd like to conclude the Crew Choice Downlink, and we look forward to continuing to work in space and all the great payload science that we're getting to do.
And Dave, we give you our sincere thanks to you guys for sending that down. That was probably the most interesting thing that Orbit 4's seen in a couple days. And you did a fantastic job of narrating. I think I can get you a job as a Capcom when you come home.
Ken, I'm not ready to come home.
The green plastic watering can for a fake Chinese rubber plant in a fake plastic girl.
Columbia, Houston, good morning to the blue team. That was Fake Plastic Trees for Willy.
Thanks, Stephanie. Radiohead's my favorite group. Thanks to my lovely wife, Lonnie, and my three handsome boys, Sean, Christopher, and Cameron. I was a little late responding because I had a razor in my hand and I was shaving in front of the mirror.
This is Mission Control Houston, now with live video inside the Space Hab Research Double Module, which is serving as the laboratory for the crew members aboard the Space Shuttle Columbia now. Payload Commander Mike Anderson is now working with the laminar soot processes experiment that is located in a combustion module. The laminar soot processes experiment has been commanded through several burn sessions inside this combustion module. Scientists are taking advantage of the microgravity environment in low Earth orbit to slow down the process of the flame reaction so that they can study them better and better understand the formation of the soot in the flame.
We're now looking at video of the mechanics of granular materials experiment in the Space Hab of the Research Double Module in the Payload Bay of the Space Shuttle Columbia. Mission Specialist Kalpana Chawla working with this experiment. Researchers on the ground have 3 of these test cells filled with sand and water, and they've been compressing these test cells to better understand why sandy compacted soils sometimes shift during earthquakes in a process called liquefaction. The same process also occurs sometimes in grain silos, causing those silos to collapse. By using the microgravity aboard the Space Shuttle Columbia, the researchers have effectively eliminated the weight of the sample, and that gives them a chance to look at some of the other variables that affect these processes. While Chawla continues working with the mechanics of granular materials, seen here, the MGM experiment, Mission Specialist, or Payload Specialist rather, Ilan Ramon of the Israel Space Agency is busy working with the laminar soot process experiment. This experiment being done to better understand how soot forms during combustion processes. It uses a flame, and that flame behaves very differently in microgravity than it does here on Earth. All the processes inside that flame occur much more slowly than they do on Earth, and that gives researchers a better chance to understand how the flame burns and how it produces soot.
That music was for Laurel, Amazing Grace by the Black Watch and the band of 51 Highland Brigade.
It's great to wake up to the sound of the pipes and inspirational music. That song brings back many wonderful memories for me and added on another one today. My husband and I got engaged in Scotland, and I send my love to my husband John and to my son Ian, who has a name originating in Scotland. Appreciate appreciate working with all you guys, and we're looking forward to a great day, too.
This is Mission Control Houston. We're back with live coverage of the STS-107 science mission of Columbia. We're getting live downlink on NASA television. This is coming to us from the MEDEX experiment, the Mediterranean Israeli Dust experiment. That experiment is mounted on a pallet just behind the Space Hab double research module in Columbia's cargo bay and includes 2 cameras. We're seeing an image of the moon from one of those cameras, the almost full moon, during this data take.
This is Mission Control Houston, continuing to watch video switch between the 6 international student payloads aboard the Space Shuttle Columbia. The Space Technology and Research Students payload is located in a shuttle mid-deck locker inside the Space Hab module. It includes the international educational payloads that students from 6 different countries developed. This live video now coming from inside one of the experiments aboard the Space Shuttle Columbia. This is the facility for absorption and surface tension, which is studying the response of surface tension to carefully controlled changes in the surface area of the bubbles or droplets. You can see in this view a bubble or droplet is formed at the end of the tube.
We're seeing live downlink from Columbia as the orbiter is just about to cross the east coast of Africa. These are shots from a payload bay camera coming down digitally. And we're seeing a cloud-covered Straits of Mombasa just below us with the orbiter on a course that will take it over the northern tip of the island of Madagascar.